Hi, it's so I'll be teaching you how many ways to add coins to a value. Problem statement. The input is an array of coins, which is called S, and the number of coins, which is M. And you also have the sum of the coins, the sum that the coins need to add up to, which is N. And the N would be 4. The output is the amount of ways you can add the coins up to the sum N. In this case, there are 4 ways to add the coins up to the sum N, which would be 1, 1, and 1, 2, 1, and 1, 2, and 2, and 3, and 1. So we have a set S that holds the coins 1, 2, and 3. M is the amount of coins that we have, and N is the number that we're trying to add up to. We're using all the coins in the set to add up to the number 4. So we split it into 2 scenarios. One where we do use the last coin, so we're adding up to 1. So we're adding 1 and 2 up to 4. One where we don't use the last coin, so we're adding 1, 2, and 3 up to 4. But since you have to use the last value, it's equivalent to adding 1, 2, and 3 up to 1. So we split it into 2 scenarios again. Where if you don't use the value 2, you're adding 1 up to 4. If you do use 2, then you're adding 1, then you're adding it up to 2. If you don't use the last value 3, then you're adding 1 and 2 up to 1. If you do use the last value 3, then you have to stop processing that branch because there are no ways to add up to negative numbers. If you don't use the last value, if you don't use the value 1, then you have no coins and there's 0 ways to add no coins up to 4. If you do use the last value, then you're using the coin 1 to add up to 3. If you don't use the last value, then you're using coin 1 to add up to 2, and if you do use the last value, then you stop processing because there's one way to add up to 0, which is by not adding any coins. If you don't use the last value, then you stop processing, and if you do use the last value, then you're using coin 1 to add up to 2. These two cases are equivalent because they're both using coin 1 to add up to 2. If you don't use the last value, then you stop processing, and if you do use the last value, then you're using coin 1 to add up to 1. Which these two cases are equivalent because they're both using coin 1 to add up to 1. If you don't use the last value, then you terminate, and if you do use the last value, then you stop processing because there's one way to add up to 0. So all these pink cases are when M is equal to 0, so there's 0 ways to add up to N. All these orange cases are when N is equal to 0, so there's one way to add up to 0. And all these yellow cases are when N is smaller than 0, and there are 0 ways to add up to a negative number. So you make the function count where you pass in S, M, and N. So when M is 0, there's 0 ways to add up to N because the count function returns 0 since there is no way to add 0 up to 4. When N equals 0, there's one way to add up to 0, which is by not using any coins. So the count function will return 1 since there is one way to add up to 0. If N is smaller than 0, there's 0 ways to add up to negative numbers. So the count function returns 0 since there is 0 ways to add up the coins to -1, not to a negative number. So you return the number from sum N, where you either not choose the last coin, so then you do So then you would have count passed in S and then M take away 1 then N. Or use the last coin, where since you know that the last coin has to be put in the sum, you can reduce the recursion problem to how many ways to add the coins up to the sum, which would be N take away the last coin.